Hey everybody, it's Luke Parisi here with the weekly dev blog on the 3D engine I've been working on. This week I've been doing a lot of different things, so I've brought up the patch notes to help me remember and go through. So first thing was that draw sorting that I was doing and talked about in I think the first video, where I had all the draw objects and then I was sorting them. Well, I was getting the distances of them and then sorting them and then drawing them in that sort order. It took up a lot of CPU power, but there's actually an inbuilt depth stencil state. I can't really say that, but yeah, depth stencil state default, and I'll show you that. So switch to desktop. I'll just do a search because I can't. Yeah. So instead of doing my model sort, get distance, which get distance was that method I made in the model render class itself, and then reverse that so that it would draw the furthest first. But instead you can just use this depth stencil state, which is inbuilt into MonoGame, and you just apply it to your graphics device. So the screen manager instance stuff you see is just the stuff I've built that handles screen transitions and everything. So yeah, and that's all you have to do, and I'll show that. We'll go scene. There we go. So as you see, it just automatically handles the distance scaling and everything, and that's handled by a GPU, so it's a lot more powerful. And I was getting, when there was 5,000 objects, it was an improvement of 20 FPS. So that's that. If you look at that sphere, it wasn't doing that with the way I was going about it before. So you can see it before it passes through it, and then so you can't see it when this is behind it, and then as it goes through it you start to see it. So that's a lot better rendering than what I was doing. I've dropped the amount of objects in the map at the moment as well, but that was the first thing that took like a minute once you figure it out. Now there's custom lighting and fog, so there were things you can pass into the models themselves when you're rendering them. So I've made it a bit darker, and there's a bit of a color, and the fog, you can't see the fog at the moment, but this I'll talk about as well, the draw distance. So this was another thing I implemented, the draw distance and FOV sliders, but I'll talk about that in a bit. So as you see there's a fog, but as well, yeah, if I look that way, with the draw distance, it will stop drawing anything outside of the distance there, and then the fog is supposed to hide that a bit. So if you look straight on, yeah, it hides it better, that the objects that aren't getting drawn and everything, it just looks smoother there. So I'll quickly show that, because yeah, these are fairly straightforward things. So here we've got the lighting, so you can use the default lighting with the inbuilt enable default lighting on the effect, and the effect is again a default shader that I'm using, because I actually did start playing around with shaders because I was trying to get geometric instancing, or I forget the other name, but yeah, instancing of objects. So like if you saw those floor tiles, they're all the same, and what I'm doing at the moment is rendering each one as a separate object. But from what I was learning, you can use geometric instancing for similar objects, but it's a shader effect, so you have to build your own shader. So I spent a bit of time on that, and I could not get that working, so I've left it for now. And the plan is for me to learn. I'm just going to try and build my own custom shader first with just mucking around, not with the instancing, the geometric instancing, but just with different type of things, so I gain another better understanding of shaders, because that was something I haven't really worked on before besides at uni. But yeah, anyway, the lighting, so you can use the default lighting in MonoGame, or you can set it to custom, which is you just lighting enabled true, and then there's directional light. So you have, I think, 3. There's directional light 0. If I just do this, yeah, 0, 1 and 2. So there's 3 there that you can apply to the model. And this at the moment, I've just got it directly facing downward, so it's like a midday sun, and that's this one here, direction. Diffuse color I've just set as white, and then specular color I have as a half red there. And then you can also apply ambient light color and emissive color. So here I've commented out emissive color. The way I was using it, I wasn't noticing too much of a difference anyway. But yeah, ambient light color it's like the so with the directional light, it's lighting from the top down. If you just use that, say for those rotatable objects, you will see the top of the model, but underneath it'll just be dark. So the ambient light color just gives it a bit of light underneath and around it on all the angles that don't get lit up by the directional lights. So that's ambient light there. Same with emissive, it goes hand in hand with ambient, but yeah, I'm just using ambient light there. And then the fog here, again, inbuilt with the effect, so effect fog enabled, and then setting the color to black, because at the moment the skybox, or the lack of skybox, is just black. So to make it fade into the background, you can set it to whatever you want. Like if I put it as grey, you'll just see the objects fade to like a fog of war type. And then you can set the start and end. So what I've done is, when I did the draw distance slider, I've just assigned a variable to that, and that gets changed based on the slider. And then I'm using that variable to determine the start and the end of the fog. So the start is just where the fog starts to become, so it goes from clear to start fading to the fog color. And then fog end is where the fog is completely blocked by the fog. So as I was saying before, I wanted the fog to completely cover the objects before they don't get drawn. So this was 50 units before the draw distance. Yeah, that can be tweaked a bit anyway, but that's simply the light and the fog, two inbuilt things. I'll switch back to scene and then go to there we go. So that's those ones. So I've added occlusion culling as well, because that was the main things I tried to focus on this week, was the occlusion culling and the geometric instancing. I got the occlusion culling working, but it's performance heavy, and I'll just show you. Stop moving collision. I'll go into those as well. So occlusion culling I have here, and this is the pseudocode I was reading. This is from the NVIDIA website, There's the pseudocode of occlusion culling there. So it, for me, it was a bit performance heavy, and it uses these queries, which again are inbuilt into MonoGame or XNA. And this is an occlusion query. So what you do with the occlusion queries is you have a query begin here, and then that starts, it starts like a query on the thread or on the buffer for the next thing you're going to do, so, or the next few things you're going to do. So here I have the query begin, and then I have it drawing basic draw of the model, which is still probably too much for it to draw. What you want the basic draw method to have is just the most simplest version of the object you're trying to draw. So here I've just got it doing or creating the position in the world matrix and everything, and doing all the transforms and drawing the mesh, and then I'm setting the alpha to 0, so you're not seeing it. And then what it does, so it starts the query, it does this basic draw, and then it ends the query. And what's that supposed to do is gets the number of pixels that have been drawn to screen based on if there's things blocking it. So as well with this, what you do is you have to make sure you're using a sort type thing. So what I'm doing here, if you want to do this for the occlusion itself, I don't think you have to reverse it, because you want it to draw the closest ones first. So with that, you get it to draw these basic draws for each object of the closest ones first. So say it draws the closest one first, gets the number of pixels, and let's say it takes up the entire screen. When it does these queries for each next model, it returns 0 for pixels drawn, because it's occluded by the closest objects. So here it runs a start query, and then I'm doing a check query to calculate the drawn pixels, which is the query of pixel count, and it waits till the query is complete. Because what happens, and this is why I'm not using it, is the query doesn't take one update tick. It might take 10 or 15 or even 30 update ticks. So what you notice is, let's say you have the object passing in front of you, it's already started a query on the behind objects before the object in front of you was there, and then it says, alright, it's drawable. So it starts drawing it, and then what you want it to do when the object is occluding the view of those behind, when it's doing that, then they'll say, alright, no pixels, stop drawing those objects. But because the queries take a bit of time, then that doesn't occur for a while. So, and what I've seen with the pseudocode, it says you have to swap buffers for each time you issue a query. And I think I still have it in the gameplay, but commented out. Don't search that, I'll search start query. Yeah. So this was what I was doing, and then I was only drawing the objects that, I was only drawing the objects that had drawn pixels greater than 0. So this was good, but it was just taking some time. So if I ran the game with this in, you would see nothing is drawn, and then probably once every 0.2 seconds or so, or 0.1 seconds, it would start drawing each object. And that's what I'm thinking is, it's because as well you have to swap these buffers as you're doing it. So you could have, say, 50 buffers doing the job instead of what I'm doing here is just one. But my understanding of it is limited. So this is what I've got implemented, and this is the correct functionality from what I understand. You just have to do this on separate buffers for each query. So that's the occlusion, and at the moment, yeah, I don't have it operating, mainly, yeah, because of if I get it swapping buffers and that, I'll use that. But at this stage, I don't even think I need it. I might go back into it when I have a high object count, so when I have, say, buildings in or dungeons in or whatever, then I can see if there's any performance improvements with occlusion there. So that's occlusion. After that, I was working on the collision. So with collision, I started learning Octrees, which is the 3D equivalent of quad trees. And quad trees I didn't even have implemented in Battle Court. I didn't have any type of collision handling system operating in Battle Court. I've pretty much got in Battle Court it's a bad system, but it's like for every enemy, say there's 100 enemies, each enemy will check collisions on every other enemy. There's no localization, I would say, of the collision. But actually, from doing this, I started working on a grid system yesterday in Battle Court, and I've only done it from player to collidables at the moment, and that's improved it by 20 FPS. But once I get to enemy collisions, that should improve it massively on high number of enemies. But that I'll probably do after this video, because I have started working on Battle Court again and gonna try and get an update out soon, beta 1.5. But I still, after doing this grid system, I'm gonna improve the off-screen frustrum, and I still have to implement weapon systems for enemies and update the bosses. So that's the plan for Battle Court anyway. But yeah, with this, so I started working on Octrees, and this was all working. So I started looking at tutorials for Octrees, and I found one example and just built off that example and gained an understanding through that. But yeah, I'm not using the Octree anymore, but mainly because the way I was trying to get the collision, I was doing it for the position that let's say the player to object collision, I was getting the node that the player was in, and then I was doing all the collision check for that node. But and this is probably the thing that I still have to learn about Octrees, is so you get the final node, which is the smallest coordinate you could fit that object in, and then what I wanted it to do was get all the collisions not only at the deepest level of that tree, but get all the collisions of the path towards that deepest level. Because let's say you have an object like the wall. I'll go into the game just so there's something to look at as well, but I can show you. So let's say the player at the deepest level of the tree occupies a space of, let's say, 50 pixels by 50 pixels by 50 pixels. So that's the deepest level. And let's say these objects here, they would have the same node depth in the tree. So if I'm near it, then I would say I'd be in the same depth in that tree and the same coordinate in that tree. So it would detect collision on that. But what I found is, let's say these floors, if this floor here was in the same node, it would detect collision on it. And then when I moved here, this one might not have been in the same, wouldn't say the same node, but the same depth. So this one was in a larger bounding box as, say, this one. And because this was in a larger bounding box, which is a higher depth in the tree, I wasn't detecting collision on it. So I needed to somehow detect collision on the path that the player model was on. I know that's not making much sense, if that's a good explanation anyway, but okay, I'll just go back to Paint. Not the calculator. Paint. So like, it's really hard to see this cursor, probably even harder for you, but this is the start of the tree, right? And I'll do it in 2, but Octrees you break into 4 for the, if you imagine a cube and then you cut it in half along one axis, then cut it in half along the other, and then cut it in half along the third, you get 8 cubes. So that's yeah, Octrees. But let's say I'm just doing it with 2 because it's just visually easier to draw. So let's say the player tree. So we start in this is the top level node of the tree, which let's say has dimensions of 10,000 by 10,000 by 10,000, and this one would have 5,000, blah blah, 5,000 by 5,000 by 5,000, then 2,500, then 1,250, and then 625, right? So let's say these six. It's easier if I just write this. This is what I should have done in the last video. So this has dimensions 625, 625, 625. So in that bounding box 625, I get all objects that occupy that coordinate. And let's say player is in this box here. So player, and then we have, like, that's the player. Let's say we have, this is one of the floor models. So we have those 2 objects in this. So then collision can be, so the way I was doing it, collision, I'm just going through all the objects in that node, and yeah, collision was detecting on this. But let's say we have another floor tile that got placed in this node, and this has a, what was it, 1250 here. So this has a size of 1250 by 1250 by 1250 bounding box. And let's say it placed it in that because this floor tile was kind of scattered along the grid, the node grid of the smaller tiles. So let's say, I'll do it with the line so it's better. So let's say that's the 625 by 625 grid. This, I'll do it green so it's the same color. Right. Let's say these are all lined up in the exact same size. So these are the floor tiles. And then you have player here. So this floor tile here, if you can see that cursor, and the player are in this small 625 by 625 grid. But because this one this one is kind of scattered, or let's say it's even bigger than the tile. Let's say it's even bigger than the 625 by 625 bounding box. Then it needs to go in a node that's depth level is one lower, so like 0, 1, 2, 3, 4 depth. So then how do you detect collision on this node? So what my solution was, you get the path that you travel to get to the final node for the player, and then you do collision on this, you do collision on this one, on this one, and on this one. So any objects in this level, the 0 depth, these would be the outliers of, they didn't go on the grid system at all, but still, I mean, that would add extra collision, but you would still do it with the way I'm kind of thinking to go about it. But yeah, I couldn't get that working. So another way, you do collision detection on the node that you're on, and then of on the same level, all the surrounding nodes. So it would have been, you do collision check on this, and then you do it on this 625 by 625, then on this one, then on this one, this one, this one, this one, and then you get it that way. But yeah, I couldn't get that working. And when I thought of this, then I realized I would just do a grid system. So yeah, I've got the Octree code still in, but I'm not using it anymore. But this is pretty much what I'll just close this. This is pretty much what I've done for Octree. So I've got the constructor, the constructor here. I've got this which creates the whole tree itself. And this happens on the load, on the gameplay load method. And then why it has this and this. So I have this to create the initial tree itself. And then I have the constructor, which is within that, and that's because when the tree is breaking into smaller segments, you just want to run the constructor, create a new node with the constructor instead of having to create the entire tree. So like let's say in the try to add child model, method. Where is it actually? There's one, partition node, that's right. So here, see? So this partition node happens when can no longer put objects in the current level node. So you break that node into child nodes, and there's 8 there. So if you can visualize, that's at the top left, let's say, but it's at the same corner, but the child node dimensions is the half of the width and height and length. So it's cubically, let's say the parent node is 2 by 2 by 2. The child nodes within it will be 1 by 1 by 1. So then with those dimensions you can fit 8, but you have to get the positions, so this exact same position, and then moved on the x-axis. I don't explain things well, but if you can visualize, it's 8. So 4 like a quad tree at the bottom, and then 4 at the top there, because you'll fit all 8 like that. But anyway, so here, I'm creating the tree itself. That gets called once. The constructor gets called in that, and every time it gets partitioned. And with the constructor as well, you can set maximum depth, node depth, which is the current depth of the node that's getting made. Propagation is how many objects can fit in the node itself. So here I'm doing it when I was creating the tree. So here, maximum depth. Propagation items in node, yeah. So I think I was setting that to like 10. Maximum depth, I've got it 6. But yeah. So what all that does is, if there's no parent, then I'm setting all them. Sorry, if there is a parent, then I'm setting them. So let's say it's this first. So we run create tree first. We create the first node, then it won't do any of that. It just gets the position, creates a bounding box based on the dimensions itself. But if let's say this is the first depth, so let's say that parent was at 0 depth, this is now at first depth when it breaks up. So the parent, this now has a parent, and then we get this propagation, so the number of objects that can fit in this node, we just set to whatever was in the parent. So let's say the parent had 10, this now has 10. The maximum depth is always the same, so 6, and then this node depth is what the parent node depth was plus 1. So parent node depth was 0, this is now 1. So if that gets higher than the maximum depth, it won't create anymore, and that's handled in the insert here. And yeah, then the position and bounding box is calculated the same. So here we have the insert methods where I'm inserting model render objects and bounding sphere. Bounding sphere was the original way, but I've actually started with model render because if I just pass in the model render itself, then I can do collision checks on the oriented bounding boxes and collision boxes and everything, instead of checking for bounding sphere collision if I was just to pass in bounding sphere object. This is faster to pass in, but I need to do, the way I was doing collision is, let's say AA, BB to O, BB collision. So I needed to pass in the model itself into the model contents list, or this one is just contents. So that's all I'm doing there. Let's say we have player and 3 floor tiles in that node. So this is where I do that. So I'm doing the player itself. I'm not doing any insert calls. I'm just getting the current coordinate it's in. But yeah, with the models, inserting them. And then what it does, it tries to add to the child node first. So here, if it's partitioned, if that node you're in is partitioned, and then yeah, for each of the child nodes. So let's say we're on node level 0, we run the insert method, which is what you do. So then it goes, all right, can I insert? So I'm on the 0 level. Is this level partitioned? Which is this here, B is partitioned. So let's say it already is. So then we go, all right, try to add child. Yes, that's partitioned. Then let's go through each of the child nodes and see if we can insert it into those child nodes. So here, so there's 8 child nodes. We say for each of those bounding boxes, if they can contain the model that you're trying to pass in. So here, if it fully contains it, we insert it into that child node. And then we return true, which then says yes, this is. So then we return. But if let's say it doesn't fully contain the model, or it's not partitioned, let's say, then it just will say, alright, try to add. False, so it doesn't do this return, it just adds it to the current 0 level node. And this will recursively run through each depth. So let's say we're at depth 5, we've inserted into 0, it'll go if try to add to child, if be partition, child nodes insert, so then this bounces back to here for the first level, try to add to child, does it for the second level, we're here for the insert on the second level, try to add to child, third level, and so on. So eventually, as long as it fits, as long as it's partitioned, as long as the model sphere fits, then it will insert it at the lowest level, or at the highest depth there. So that's what I mean when I'm saying before, when some objects, if they're not fully contained in the node, they'll get inserted into lower levels of depth in the tree, and that's the problem I was having there, and why I wanted to find that path so I could run collision checks along that path. So that's that system there. Try to add to child nodes there. Now here it's just getting Octree. This I was just using to write the screen. That's all I was using it for. But it's bad because I got this string here, and then I'm getting Octree, and then trying to pass that string into the tree res string, and then when I'm writing it to screen, I'm saying if it's not null, if it's not blank. So it's kind of crappy this, but I'm not even using this anymore. Well, I'm not using the entire Octree anymore, but yeah, that's this. Get tree node is, what was this doing again? Get tree node. I can't remember what this was doing. I think this was getting the node. I'm pretty sure this was getting the node that the object was in, but I'm not using that. This was pretty much the exact same as this, except this is cleaner and just returns a Octree node instead of a string. Well, this returns void, but this is still getting a string. And then the add and remove, I've got to remove that wrapper as well, but the add and remove, where's add? Oh yeah, inserts, and then remove. So if you have moving objects, and I do have them here, now I'm using the grid, but it's exactly the same. If these objects are moving per frame, I'm removing them from the Octree. For here, I'm using grid, and I'll go through that next. But yeah, I'm using each frame, I'm removing from the grid, doing the movement, and then adding to the grid again, which was the exact same what I was doing with the Octree. So I was removing them from the grid itself, from the Octree itself, sorry, and then doing the translation, and then adding them back to the tree. So that if I did it because the movement might change the node that it's in. So it's like that for those models, and it was like that for player, because the player is constantly moving. But yeah, enemies and that, and this is, at the moment it's not a problem in this, but it's more of a problem in Battle Court. So in Battle Court there's a lot of moving enemies, so what I will be doing, instead of removing each from the grid, I'm just going to be clearing the grid itself of all enemies, and then re-adding them. And it sounds like it's more, but compared to the way I was doing it, it's actually less calculations. Because if you think about it, the way, and I had a way, I have it so let's say there's 100 enemies, it's not n squared, it was actually I can't remember the name, but 100 exclamation. Yeah, if you know what I mean. So that means it's 100 times 99 times 98, and that's still a lot, but yeah, that's the number of calculations it's doing at the moment in Battle Court for, yeah, let's say there's 100 enemies. If there was 500, then it'd be 500 times 499 times 488. So that's a high number of calculations. But let's say there's 500 enemies with the new way, then I just remove 500 enemies from the grid, re-add 500 enemies, and then I do the localized collision checks, which might be, let's say, I don't know, 1,000 only. So that's way less calculations than the way that it's doing currently, without a grid system or Octree or anything in place. So that's, yeah. Anyway, that's the remove. And then the partition, as I was talking about before, so this just partitions the nodes into the 8 child nodes, which have half the width, depth and height of the parent node. So that means you can fit 8 in there. And then this is the try to push items. So if it gets partitioned for the contents, I actually should have been doing this for model contents as well. Then it tries to push it to the lowest. And then here. Tries to add to child, and then it removes at the parent node that it's in. And then intersects. It's just, yeah, I'm not using this because this is array, and that was part of the examples going through. And then, yeah, tree contents just returns a list of the contents. So that's the Octree, and I got that working, but not with all the collision working. So this Octree has, if you're going about an Octree, this has what you need, except for it's not doing the collision calculations, which, as I was doing in gameplay. So instead of using Octree, I switched to grid. So here, yeah, see here, this was where I was doing the Octree collision. So for all the nodes, I was getting the tree node with the player tree sphere in, which is the current node that the player is in the tree, and then I'm getting all the objects that exist in that node. So I0, I less than the count of those objects. We then do collision check of player model tree of that node's model contents, and player model collision is, if I go into collision, player model collision is pretty much the exact same. Well, yeah, it's the same method I wrote in for the last video. So I'm just using that same method and passing in each of the models in that node. So yeah, what you want is this plus getting the surrounding nodes, or maybe even getting the objects in the path towards that node as well. But yeah, so I had that, wasn't getting all the collision, and then switched to grid, which is a lot simpler. So the grid is broken up into the grid coordinates 2D array of size x max, z max, which is I've just got as 1,000, 1,000, and then that just adds all those coordinates here. So in grid coordinate object, it only just has models list. That's it. In Battle Court though, this has enemies in coord, this has collidables in coord, and then in Battle Court as well, I'm going to actually have 2 grids, one grid as the wide grid and one grid as the smaller grid, And for the wide grid, I have the, say, player to collidable collision detection, enemy to collidable collision detection, and in the small grid I have enemy to enemy collision detection. I have it that way because the collidables have large source recs, and it's not as performance heavy for, let's say, enemy to collidable detection and player to collidable, even bullet to collidable. It's not as performance heavy. The only one that's performance heavy really is the enemy to enemy collision, even bullet to enemy. But that having that in a smaller grid means that there's going to be less calculations required. So less enemy to enemy collision calculations required with a smaller grid. So yeah, anyway, this is the grid. Add to grid and remove from grid. Works the same as the Octree insert and remove. So here you can see I'm using those methods, each update here for these moving objects. So again, in Battle Court, I would have this just clear the entire grid, and then I add again all the enemies. But here, because it's just these 4 planes that are moving, I'm removing them from the grid, doing the movement, and then adding to the grid. And then you do all the collisions. So I have that there for those moving objects, but up here for all the objects, for all the static, it's here. So the test cubes, test planes, and the ramp. So that here you see this was where I was doing the tree insert for those as well. But yeah, I'm adding to the grid here. So these adds, if I go into it, it adds to the grid based on the model's grid position X and Z, which is simply their position X and Z divided by 100. And this actually, as I have in Battlecore, I have that as a global in Screen Manager Grid Divisor. So here I've just got it as 100 at the moment, but once I start working on it again, I'll just switch that to Screen Divisor Global Variable. So this just gets that, divides it by 100. So that's 100 at the moment, as the grid has dimensions of 100 by 100. On the XZ, the Y, I'm just keeping the entire length. It's pretty much like how Minecraft handles it. They have the chunk of, whatever dimensions, and the Y-axis is pretty much the entire top to bottom. So that's exactly the same kind of system here. So with the grid, so it gets the model based on its position. That's where its grid coordinate is. Same player works exactly the same. So here I have the grid X and Z here. And then I've got these, if grid is less than 0, it's equal to 0. So if anything moves to behind or off the map itself, then it just assigns it to the 0, 0 coordinate. There shouldn't be any objects or many in the, once this is a game, there shouldn't be many that have that happen. So that's that. And then you might want to have a max as well, like if it goes over 1,000, set it to 1,000, or over the grid X max or Z max, whatever you set it to. Then and I will need to do that in Battle Court, because the small grid will be 32 by 32, and then some enemies will be off screen and in a grid coordinate. That might calculate to over 1,000. So, I might change these to 2,500 in that, but there are ways to go about it. Anyway, so that's the grid. It adds adds these objects to the grid at their coordinates. And because these are static, these don't move, you don't need to keep updating them. So the only ones that needed to be keep updating is the player and the anything that moves. So to calculate the collision on that, so now with that grid system, which is a lot simpler than an Octree, and the main difference between having a grid and an Octree is the Octree dynamically can update for different sizes, because some objects might be really small, some objects might be large. And how do you do that in a grid system? Like what grid dimensions do you put? If you put small, then the large objects you'll never get collision on because their grid coordinates are so far away from your own. And if you have it too big, yeah, you'll get it for the big objects, but then the small objects, you might have a heap of the small objects like the enemy example in Battle Court. So for that, instead of doing Quadtree, I'm just got a grid and I'm doing two separate grids. One, the large grid, one the small grid. But yeah, they're the main reasons you want to use an Octree or Quadtree over a grid, is because it dynamically adjusts the grid, the tree node size. But yeah, for what I'm doing, a grid works nicely. So player collision. So this is a new method. So all this does is it gets the player and the grid, and then checks for collisions on the coordinate that the player is currently on. So let's say player's on coordinate 1010. Here it gets for each model in the coordinate. So this might have 0 models in that coordinate, so it just doesn't run that. But let's say it has 1, then it runs the player model collision method here, and then it gets if AABB to OBB or ABB to AABB, that same method that I wrote for last week. So it just runs that only for the models in the coordinate here and in the surrounding coordinates. So here it's exactly the same except for each. So if you imagine your coordinate and then the 8 cells around you, the 8 coordinates around you, you want to detect collision on as well, because some models might be in that coordinate next to you, and that's where the size of the grid, the size of the grid is important, because if it's too small, then even the coordinates next to you might not contain an object that you're colliding with. And if it's large, then yeah, you have the problem of too many objects in the coordinate. But yeah, with the dimensions, I've got 100 by 100, and I'm checking the current chord and the surrounding coordinates. So yeah, here, grid X, grid Z, this is grid X right, grid Z forward, which is here. Grid X right is grid pos -1, and grid Z forward is the grid Z +1, and then I'm just making sure it doesn't go under 0. So it doesn't check if it's under 0, which it shouldn't, but yeah. If grid X is -1, let's say grid X was -1, then I'd be passing in -1 here, which throws an error for a 2D array. There's no -1 coordinate or position. So yeah, that is fairly straightforward. It seems like there's a lot, like you got a 4 here, 4 here, 4 here, but compared to not having this and having like the way I was doing in Battle Court, the n squared collision calculation checks, or I think it's the absolute pretty sure it's called absolute, the n absolute number of collision checks. This is way less. This is way less amount of collisions, because you might have 1,000 models and then only 50 of them occupy your coordinate or surrounding coordinates. So there's if it's 1,000, if it's n the squared number, then that's 1,000,000 collision checks. So obviously that's not good. And even 1,000 absolute, that's 1,000 by 99, 999 by, so what's that? That's less, but it's still high. And then you have this, which is 50 total. So that's way better. Update position, I think that was new as well. Yeah, that's going into the collision itself, which is new now. So yeah, that's the grid that I'm using now. So now in collision, I'll go into that. I'll just check the patch notes. So yeah, this is part of collision now as well, model render. So I've added model type enum, which gets if the model type is a wall, floor, ramp, and all that. So because of that, I'd have different type of collision working now. So I'll just show you the collision itself. So here I'm colliding with the floor at the moment, and that just affects your Y axis collision there, so it prevents that. When it's an object like this, well, that scared me actually. So when it's a ramp, when it's an object like this, it turns it into a ramp. And then if it's a ramp, it does pretty much the same as a floor object, except it adds a push-up movement to you until you no longer collide. So that's, as you see there, it lifts you up and then you collide. Same with like these rotating objects. Well, that's exactly the same, but double axis rotation here, exactly the same. And then there's now, if the model is translating, so like here, this one's moving upward, then as you saw in last videos, you get stuck in the position, but here it's moving you upward with it, and that's actually not the same functionality as the ramp. This is it's getting the translation amount of the object you're colliding with and moving you that exact same amount. It does it with the ones that are moving in the X and Z axis as well. Only difference is it's not moving correctly at the moment, so I'll try and, so if you see here, it's moving me, but it's not moving me at the same rate because half the time I'm not colliding with it. And then here's a static ramp. So this one's not rotating. This is just because it's been rotated once, it converts it from a floor model type to a ramp, and that you get this jitter. So that's because it's that continuous up movement. But that allows for you to move up and down the ramp. So the floors don't have that continuous up movement, otherwise you would see that jitter on the floors as well. But yeah, with the ramps, it has that jitter. So this is just the system I have in place at the moment. If you hit the bottom of the ramps as well, it pushes you up through them. And then you have walls. These have wall type collision, which I have to tweak as well, because if you hit it at an angle, see like that, you can go through it. But I need to bring in larger objects to test against instead of these spheres. And yeah, that was another thing. I just brought in these spheres instead of the cubes that were. And then yeah, if you land on the top of a wall, I press back and it moves forward. So yeah, I'm still tweaking the wall type collision there. So that's the collision at the moment. That's those ones there. Now FOV Slider and Draw. Oh, I also updated the keybinds here, so fire, weapon, inventory, all the other ones from Battle Court are now gone. I added jump and crouch, and then yeah, added the sliders, FOV sliders, which you can update in game. So that just goes from 100 to 1600 at the moment. FOV goes from 50 to 150. That you can update on the fly. There's my max FOV. Let's bring it back. So I'll go through them now in the code as well as the collision. So collision first. Other than that, the collision, this I'm just updating. I don't think I'm using any this. Yeah, final references. I am. Update position. Yeah. Updating position. Yeah, this is the one that moves the player itself. So if it's colliding with an object, then I call this update position, which here, if there's any translation effects like that movement, then I'm updating the previous position, which is what it snaps to. If there's a collision, say on a wall, then if I'm moving forward and it collides with a wall, then I know don't move forward, just keep the previous position. So here on floor, I'm just axis align. So if the model type is model type floor, which is those flat floors you see there, then I'm just minusing from, I'm just subtracting cam position back to the previous. This is pretty much the exact same, the previous, because as you see here, it's the cam position minus the previous. So this is a vector that you moved. So this is your movement that you did in that last frame. So if there's a floor collision, I just minus that movement you've done in that previous frame. So here only the y-axis. So for this would be let's say you're not moving, gravity would still apply. So your cam position would be this. Cam position would be, let's say you've dropped 1.4 units, then this would be res pos would be 0, 0, 0, 1.4, 0. So you're 0 on the X and Z and 1.4 on the Y, because that's the gravity trying to drop you. So this is just reverting that gravity fall. If it's a ramp, it's the exact same for all. And so with just these two in place and not this, I'll just show you with it commented out and you'll see you actually get stuck. And that's kind of good. So if I go to that ramp now, you'll see, yeah, see, I can move down because that's where I'm no longer colliding, but I can't move up. So here I'm trying to move up, and yeah, or if you hit the side or the bottom. I mean, that's why it's good, because that works as proper collision. The only thing you can't do is move up the ramp. So there, this can be perfect for, say, a roof or even a wall. Then the only thing I'm doing differently, so I'll show you that anyway. So yeah, that's without this constant upward momentum when you're colliding with the object. So when you're colliding with the ramp, it pushes you upward, and that allows you to be climbable and let's say on those rotating objects, it allows you to be pushed up with it. But wall is the exact same. The only thing I've added for wall is this, and that is what I'm trying to do here is, let's say you collide with the wall at a 45-degree angle from the wall. I'll bring up pane again. So let's say you have the wall here and you are approaching the wall at this angle. Then yeah, you hit the wall, prevent any movement, right? So you get to here, you get to there, then I want it to prevent any more movement, right? But if what I'm doing, so that's this here, it prevents any movement. But what I also want it to do is I want it to still allow movement in this direction. So say you're still facing this way, then I don't want any movement here, but I want movement along this axis still to be allowed, and that's what I'm doing here. So if any of the keys are pressed, then cam position X. If you're, so with this, I'm saying if it's less than the model box, the collision box min X or the max X. So if, let's say this is the X and Z, because we're looking top down. I'm saying if the, let's say the Z axis, right? If the player Z axis is less than the minimum, which is this, the minimum of the collision box's Z axis. So if it's less, or if we're colliding from this direction, if it's greater than the maximum, then, so that's, and the same for X, if either of those collisions, then I'm saying we're keeping the, so for X I'm keeping the Z axis, and I'm getting the yaw vector, which is the angle of rotation that you're currently at, and then I'm still incrementing the Z relevant to how it should be incrementing. So, you know, based on your angle, if you're at a 45 degree, say your move speed is 1, then this would be 0.5. So the Z axis is still moving correctly during that collision, but the X axis isn't. And the opposite for the Z, then you do it for the X. But yeah, that's still not correct, because this allows for you to pass through if you're hitting it on the corner. So I have to tweak that a bit. And yeah, with Battle Court as well, collision was something that I spent so long trying to get right, and still got, I think, a lot to learn with collision, especially like these ramps. If there was a way to get the rotation and then translate your forward vector to that with that rotation. So let's say instead of moving forward with a Y of 0, when it hits a ramp, then it should increment the Y. Then the forward should have a Y direction as well. But yeah, I think I have a bit to learn with that. So that's the collision there. So last thing I think to go through is the FOV and the view distance. So options, I've just added those sliders in, which is here, slider back FOV, slider knob. Yes, sorry, slider FOV and slider draw distance. And just drawing it to that options menu. So this functionality is all what I set up in Battle Court, but this is for the sliders themselves. So let's say, so here I'm just checking if what's the slider you clicked, and then if it's clicked, so if you're not intersecting with the slider or knob itself, still slide it if your mouse is down. And then these are the calculations for getting the value. So global FOV is from 50 to 150. So I'm just, the width of those sliders is 300 pixels, so I'm just dividing by 3, and then getting that position as well. So you know, it's at position 500, then getting that position X as 500 as the 0 point, and then yeah, that's all this is here. And then just basing the global FOV on the difference. So that calculation is just simply the difference between the position of the back and the knob. So let's say there's a 50 pixel difference, or because it's 300 actually. So let's say there's 150 pixel difference. So you're halfway between the back there. Then you get your 150 pixels difference divided by 3, which is 50, and then I'm adding 50, which is the flat. So that would calculate as 100 there. And then yeah, here I'm just reverting from what I remember. So that's all that is. And then the global, and that we're using those values in where is it? Gameplay, I think. And I'll just go back here. So FOV. So FOV isn't calculated each frame if you're not adjusting the global FOV. So if I go to, so it starts at 70, and then let's say you don't have any ini file. That's this as well, save ini. So if you don't have an ini file, or the ini file is corrupted, it reverts it back to 70. If you make an adjustment, it saves to ini that FOV value. That's these ones here. Yeah, I'm drawing to the options menu. Now where was I using it? Here. In options. Oh yeah, so I'm updating the projection matrix in the options. It was right in front of me, jeez. But yeah, so as I change if I change the value, then I update the projection matrix on the fly when the value is updated. So that's here, projection matrix, create perspective field of view, and then I'm passing in the FOV and the draw distance. So this gets updated on the fly if there's a change. So the scope of this here is if the mouse is clicked on draw distance slider clicked, or I have the same on the FOV slider. Now that's the sound. So there's the draw distance, and where's the FOV slider? So here I have that exact same. So in the scope of if the FOV slider is clicked, then I'm updating projection matrix on the fly. Same with if in the scope of if the draw distance slider is clicked, then I'm updating projection matrix on the fly. Otherwise, yeah, it just does it once based on those values when it loads in, or if you're on it. And yeah, I think that's everything. That's those two. Keybind list, yeah, I went through. Grid collision, went through. That's the translation that was in that same update coordinate method. And yeah, so stop movement, that's in the wall. Yeah, I'm pretty sure that was everything. So that was everything I did this week. And then yesterday I started adding that grid as well to Battle Court. So, which I might do, spend a bit of time on this week, is working on Battle Court. But what's next with this one itself, this game, is I might start playing more with the walls, and I might even build a procedural gen type system of say buildings or dungeons, so that I can start working with the collision a bit better. But so and that's another thing, I'll have to start making some more models in Blender with some textures as well and that. But yeah, that's the plan for this week, guys. This video, again, I can see an hour 15. So these videos are going for a while, but I hope I go through the code a bit and explain things well enough. But I do this all in one go, so I don't even plan what I'm going to talk about beforehand. I just go into it and start talking. So explanations aren't the best. Like even with what I was going through with the OBB in the video last time, when I went through it again and went through it, I know I could have explained it better, but yeah, doesn't matter. Yeah. Anyway, thanks for watching, and I'll see you in the next video.